We are continuing with the problem where we have the curve y is equal to cosine squared of x minus 2 sine of x, where x is from 0 to 2 pi. We want to find the concavity, points of inflection, local maxima and minima. We already found the local extrema, which comes from the first derivative. So let's copy down the first derivative, what we had before. Y prime is actually negative 2 cosine of x times sine of x minus 2 cosine of x. So we're going to now find the second derivative, which of course means we're going to use the product rule. So the derivative of sine is cosine. And the derivative of cosine is negative sine. But I already had a negative sign here, so my next term is going to be plus 2 sine squared of x. And again, the derivative of cosine is negative sine, so the derivative of negative 2 cosine of x is plus 2 sine of x. So we found the second derivative. The second derivative is negative 2 cosine squared of x plus 2 sine squared of x plus 2 sine of x. Now, what I'm trying to do is find points of inflection, which is where the second derivative changes sign. So I can factor out a 2. So we have 2 times negative cosine squared of x plus sine squared of x plus sine of x. Now, what we need to do is get this expression in terms of either sine or cosine. So what we'll use the fact that cosine squared of x is 1 minus sine squared of x. What I actually have here is negative cosine squared of x. So negative cosine squared of x is negative 1 plus sine squared of x. So what I'm going to do now is I'm going to replace negative cosine squared of x with the quantity negative 1 plus sine squared of x. So what that tells me is that my second derivative, y double prime, can be written as 2 times, again, negative cosine squared of x. I'm replacing that with negative 1 plus sine squared of x. Well, I already had a sine squared of x there, so what I'm going to end up with is 2 sine squared of x. And I have a plus sine of x and a negative 1. Now what you have to realize is that this quantity right here can be factored. It's like if we wanted it to factor the polynomial expression 2u squared plus u minus 1. I'll give you a minute or two to do that, and we're going to finish this problem on the next video.